We've moved past messy, chaotic AI outputs that morph every few seconds. Instead of hoping for a lucky prompt, you can now generate a flawlessly realistic, cinematic poker scene exactly like this. This result is the product of a 5-step filmmaking formula designed to bring structure and predictability to AI video generation. Most creators struggle to get these results because they try to force an AI model to juggle character details, complex lighting, and specific actions all in a single prompt. When an AI has to multitask everything at once, the output breaks down. To fix that, we are going to use a specific workflow combining Pinterest and Claude, Higgsfield Cinema Studio, and a basic video editor. You do not need any prior filmmaking experience to execute this. Photorealism requires a structured director's workflow, isolating each variable and building the scene through a sequence of individual, controlled tasks. Step 1 is the vision. Before you open up any video generator, you define the aesthetic by building a mood board. Collect 5 to 10 reference images that match the exact mood of your scene, arranging them onto a single board in a tool like Canva. Take that completed mood board, drop it into an AI assistant like Claude, and add a simple 2-sentence description of your story, basic character traits, and the emotions you want the viewer to feel. Ask Claude to synthesize that input and return a complete structural blueprint. You need tailored, specific prompts for your characters, for your locations, and your actions. Investing effort into this blueprint upfront eliminates the random trial and error that causes messy, disjointed generations later on. Force character traits, lighting setups, and action into a single bottleneck, and the AI scrambles the variables into a broken output. The solution? Separate variables into distinct pathways. Process each ingredient on its own, starting with the human. Using the Cinema Studio feature in Higgsfield, take the precise character prompt Claude generated for you and render a dedicated cinematic portrait. Once the image matches your vision, click Save and name it. This locks the facial features and style of your character into a persistent library. Step 3 applies this exact same isolation technique to the environment. Use the Cinematic Locations feature to render the environment. Because creating these specific location assets costs significantly fewer compute credits, you can safely set the resolution to 4K right from the start. Review the generated environments and save the best one directly into your asset library alongside your human character. Creating this locked library of isolated, high-quality assets is the mandatory foundation for maintaining visual consistency across every shot of your final video. Step 4 is where we put everything into motion. We move into the AI director phase to synthesize those static assets into actual video clips. Paste the story blueprint you got from Claude into the AI director. It will automatically read the text and apply the best camera angles, styles, and genre settings for your specific scene. Drag the saved character and location from the library into the Reference Element section, explicitly tagging them in your prompt. Before hitting Generate, set the video resolution to 720p. Rendering these initial drafts at a lower resolution uses 4 times fewer credits, allowing for more experimentation. When you generate multiple clips, the biggest challenge is maintaining exact environmental and lighting continuity from one cut to the next. Add the last 5 seconds of your previous clip as a reference video. This ensures your next shot starts precisely where the first one ended. Bridging consecutive shots with that reference data ensures the lighting and room geometry carry across both angles. This eliminates the jumpy, morphing backgrounds that often give away AI generations. For Step 5, we move outside the AI generator. Export all your finalized draft clips and drop them onto a timeline in an editing software like CapCut or DaVinci Resolve. Clean up your cuts. Then lay down a low-energy, continuous cinematic music track underneath the dialogue to establish a baseline mood. This timeline view illustrates the final layer, specific physical sound effects. Without the subtle click of poker chips or a champagne pop matching these audio spikes, even high-quality footage feels disconnected. Adding Foley tricks the brain into accepting the visual data as real. Once the audio mix is locked, export that complete sound design sequence back out of your editor. Bring that file back into the AI environment and use the Upscale tool to elevate your completed 720p cut to maximum resolution. High-fidelity sound design combined with targeted upscaling pushes an AI generation out of the uncanny valley and into reality. Here is the final result. The environment holds, the character details are locked, and the atmosphere feels authentic. This level of quality is possible because we moved away from single prompt methods toward asset isolation and post-production polish. Check the links in the description to access the tools we use today and start building your own cinematic asset libraries. By breaking the process down into strict, manageable steps, this workflow makes high-end visual storytelling accessible to anyone.